Welcome to qnawire.
Hello. In the question we have given that a chauffeur is driving a car along a straight road at a constant speed. So we will call this as VC, that is equal to, that is the velocity, the speed of the chauffeur. So that is equals to 22.5 meters per second is given. Just he passes the law office officer parked alongside the road. The officer starts to accelerate. So acceleration of the officer is given to be 0.5 meters per second square. So to overtake him, so assume that the officer maintains this acceleration. So determine the time it takes the officer to reach the chauffeur. So now over here, what for the time, let the officer let the officer sorry let the officer catch or overtake the chauffeur at time t. So now what is the distance traveled? So distance covered by chauffeur, let us call it as dc, that should be equal to vc times t, because constant velocity means acceleration is zero. So actually we are using the equation s is equals to ut plus half at square, but as the it is constant velocity, the acceleration will be equal to zero. So that is why we are writing this. Now the distance covered by the officer, the distance covered by the officer will be, so we will call it as do, that is equals to just a 1 by 2 AO t square, because same we are using s is equal to ut plus half at square, but over here the initial speed is 0, so that is why just half at square remains. So now when both so when officer catches when officer reaches chauffeur, so what will be the condition? So dc should be equal to do. So the distance traveled by the chauffeur will be equal to the distance traveled by the officer. So it will be vc times t, that is equal to do is 1 by 2 AO t square. So from here this one of the t's get cancelled and we get t as equal to 2 vc divided by a naught. So it will be 2 into vc over here is 22.5 divided by 0.5, and this gives us the answer as 90 seconds. Now with this, in the second part they are asking find the speed of the officer. So the speed of the officer will be equal to, so we will use v naught is equals to u plus at, but u is 0, so it will be 0.5 times 90, so that gives us 45 meters per second. Then the next part is, so find the total displacement. So total displacement will be do is equal to 1 by 2 AO t square. So that will be 1 by 2 into 0.5 into 90 square, and if we calculate this we get DO as equals to 2047 2047.5 meters. Now the next part is, so determine the answer. So they are saying that it is accelerated 1 minute later. So this, rather than immediately accelerating this officer, so with that, so DC will be equal to VC times T, then DO will be equal to V, sorry, it will be 1 by 2 AO into T square. But now T for officer will be T minus 1 because it is time taken is T, but it is traveling 1 second later, so it will be T minus 1. So with this, if we calculate this, so DC will be equal to DO. So we can write this as 22.5 T, that is equal to 1.2 into 0.5 into T minus 1 square. So this will give us half into 0.5 T. We can write this as T square minus 2T plus 1, and that is equal to 22.5 T. And if we solve this, we will get this one quadratic equation, that is 0.25 T square minus 23T plus 0.25, that is equal to 0. Now this is a quadratic equation, and if we solve this quadratic equation, we will get T as equals to 91.58 seconds. Now with this, VO will become U plus AT. So E is 0.5 into 91.58. So with this, we will get the speed at end as equal to 45.99 meters, and the displacement DO will be 1 by 2 AT square. So if we plug the values and calculate, we will get this as 2115.08 meters. I hope you find the solution useful. Thank you.